Hey everyone, Mr. Newman here, and today we're going to learn about parts of a quadratic. So I wanted to show you guys this picture first, and I want you to notice also that a quadratic is just the equation that graphs a parabola. So sometimes I'll say quadratic, sometimes I'll say parabola when I'm talking about the shape. The function for this graph is f of x equals x squared plus 2x plus 8. And notice there's a square in there, x squared, that's what makes it quadratic, and that's what makes the shape of the parabola. Also, I want you to notice these are a lot of words we're going to learn here on the left, and some of them mean the same thing. So I want you to notice that. I'll point those out, and that will help you have to learn fewer vocabulary words. So let's get started. First of all, notice the point down there at the very bottom. That's called the vertex. The vertex is 1, -9 on this parabola. And the vertex is just the point at the bottom, or if the graph was flipped, the top of the graph. The solutions are here and there. You see the two blue dots I made at -2 and 4. So x equals -2 or x equals 4 are the solutions. And we call them solutions because they're the solutions to this equation up here. If we made 0 f of x and said 0 is equal to x squared plus 2x plus 8. We just worked on that in class at the end of last semester. And you know that we also call those zeros. So the zeros are -2 and 4 because that's when y equals 0. They are also the x-intercepts. And I write those as points because I think of x-intercepts as points. So -2, 0 and 4, 0 are both points on the x-axis, which makes them x-intercepts. All three of those are virtually the same thing. The solutions, the zeros, the x-intercepts. So don't be fooled if I ask for one or the other. Those are all the same thing. The y-intercept is a little bit different. It's the point on the y-axis. And that point is 0, -8. Make sure you have your x and y in the correct place. So 0 left and right, and down 8 is -8. The maximum, there isn't one for this graph because we only have a minimum. And the minimum is at that point down there. Notice I put little arrows on the top left and top right because this graph, all parabolas keep going on forever unless they are otherwise specified, unless they're in a situation. And that means there's no maximum. It keeps getting larger and larger. But there can be a minimum when the parabola points this way. And the minimum is the same as the vertex. Notice that. The minimum is at the very bottom of the graph. You can also call the minimum just by its y value. So the minimum value you can get out of this function is -9. So y equals -9 is the minimum. Concavity is a funny word that has to do with the curve of the parabola. So I have a saying, a phrase that helps me remember: up like a cup and down like a frown. You guys can picture a cup curving upwards and a frown curving downwards. Those are the two possible concavities: positive or upward concavity and downward or negative concavity. This parabola is up like a cup. So if you want to write that mnemonic, cup and frown, that helps you remember up and down as the concavity. The end behavior is both positive. The reason for that is because if you look to the left and look to the right, both those sides of the parabola are pointing up. And for all of our parabolas, they'll either be both positive or both negative. The axis of symmetry is the vertical line over which the parabola is symmetric. In other words, if you flip the parabola over this line, it will land right on top of itself. Here, I'm going to draw a dotted line. I want you to do that as well. Draw a dotted line over the axis of symmetry right there, and that's because the axis of symmetry always goes through the vertex. So it's always the x value of the vertex. In order to draw a vertical line, we have to have x equals, and you notice 1 is the x value of the vertex right there. So those values overlap as well. So if you know the vertex, you can find the axis of symmetry. X equals 1. You can go ahead and write down the definition. It's the line over which the parabola is symmetric. Next, I already gave you the equation, so I'm going to write that down again. F of x equals x squared plus 2x plus 8. Recall that domain are all the possible inputs. And on a parabola, you can plug in any number. You can go as far left or as right as you want. I could plug in 2, I'd get negative 8. I could plug in 3, I'd get negative 5. I could plug in 4, I could plug in 0.2, 0.5, any fraction or decimal. So when all possible inputs are allowed, we write it like this, from negative infinity all the way to positive infinity. Another way of saying that is all reals, and you can write that down either way you'd like. For the range, that's all the possible outputs, or all the possible y values. So here, we actually can't plug in just anything because, for example, we can't get out anything. We could never get out the value negative 10. There's no point on this parabola that has a y value of negative 10. The smallest y value, remember our minimum, is negative 9. So we need to say that. It's basically negative 9 and up. The way we say negative 9 and up is we write down negative 9, that's the range, negative 9, and notice I use not parentheses but this bracket because we can actually get an output of negative 9. That happens at the vertex. And comma, infinity, because it's everything going on to infinity greater than negative 9. Another way to say that using inequality is saying y is greater than or equal to negative 9. For the last two things, increasing and decreasing, you just want to think walk to the right. Sometimes I think of an ant crawling. And so I'll show you guys real slow motion here. Moving as you go to the right, notice the green line that's moving there. What's happening? Well, as you go to the right, you're going down on that part of the parabola. That means that we're decreasing on that side. Meanwhile, on the right side, as we go to the right, we're going up. That means we're increasing on the right side. So we're decreasing on the left side of the parabola, increasing on the right side. We just need to know how do we write that. The way you write that is using the interval notation again. So we're decreasing from negative infinity all the way up to 1. In other words, we're decreasing up until x is 1. And notice we're writing this in terms of x because we're going left and right, and that's our x value. We're increasing from 1 all the way to infinity. In other words, we're increasing after everywhere after x equals 1. And those are all the parts of the parabola. For this next question, I'm going to give you an equation, and I don't show you any kind of graph. However, you need to know that calculators are allowed. So get out your calculator, and I'm going to show you some steps. First thing we're going to do is we're going to learn how to type that in, and we'll fill out this table together. So on your graphing calculator, you need to turn it on. And notice I'll circle the buttons you're going to press. So just follow along. Go back and watch the video again if I lost you. We're going to press y equals. That's on the top left of the calculator. When you press that, you get the y equals screen. From here, we can type in the equation into that first point. So type that in. Notice you can use the x button is right there next to the alpha button. It's x, t, theta, n. X is the way it works for us. So you press X, and you can press this button for squared, and then minus. Notice there's minus and negative. Don't be confused between those. Use the minus for the operation and negative to make a number negative. So here we're going to use minus 2x minus 3. And when we do that, we want to press the graph. Now, if your graph does not look like this right here, then what you do is you're going to press the button zoom and then 6. So the zoom button is right here, and just press the button, the number 6, and you should get a graph that looks just like mine. So let's talk about this graph now. What I'd like for you to do is press the trace button. That's right there next to zoom along the top. And when you press that, notice that x equals 0 and y equals negative 3 popped up. This is nice because that's our y-intercept, 0, negative 3. Notice some other features of the graph, that the vertex is right there. The x-intercepts are there, and we have the axis of symmetry is right there. Now, as you're looking at this, I can't necessarily tell what these values are, so I'm going to show you how to navigate around within the values, because we don't know what the numbers for the vertex are. So what I want you to do is I want you to press the right arrow, and keep pressing the right arrow until you move that little dot to the right. I had a teacher that called that a spider, and so I guess I'll call that too. So the spider, you want to move it all the way to the right until it gets to the very bottom of the parabola. You might have to go left or right, but you should get some numbers that look like this. Notice that x is not exactly, but it's kind of close to 1 when it's at the bottom there, 1.06. And notice the y value, negative 3.99, that's really, really close to negative 4. However, to be absolutely sure it's that point, what I'm going to do is I want you to press the number 1 while you're in this mode. Once you press 1, your screen should look like this, and you're going to press, see the 1, x equals 1, and you're going to press enter. So what we just did was we just asked our calculator to figure out, well, when we plug in 1, what do we get out? And lo and behold, we get out the point 1, negative 4. Negative 4 is the output when the input is 1. And that is indeed the vertex of the parabola. Yay. So, we found it. That's also the minimum, so we can fill out that part of the table too. Now, to find the x-intercepts, what I want you to do is go to the right all the way until your spider is right on the x-axis. Notice our point looks really close to 3, 0, because negative 0.08 is really close to 0. And we're going to do the same thing. We're going to type in the x values, so type in 3, and you should press enter once you get x equals 3, and you get 3, 0. Notice since the y value is 0, we're absolutely sure that this is the x-intercept. Go ahead and make a guess what you think the other x-intercept is. And we'll type that number in just a second. All right, did you guess negative 1? Well, I did, so when I press enter there, when you press enter, after typing in negative 1, then you get negative 1, 0. So that is the other x-intercept. So we have a vertex, both x-intercepts, we have the y-intercept, and that's enough for us to fill out this table. If you haven't been filling it out, I'll go ahead and fill it out quickly with you. So the vertex, and also the axis of symmetry. Notice the axis of symmetry is the x value of the vertex, like I mentioned before. So let's fill this out. The vertex is 1, negative 4. Our solutions, those are the x-intercepts, are negative 1, 0 and 3, 0. The y-intercept is 0, negative 3. We don't have a maximum because of its concave up. The minimum is 1, negative 4, or y equals negative 4. That's the vertex. The concavity is up like a cup because it's curved up. And the end behavior is both positive because on the left side and the right side, they're both pointing up. Every time it's concave up, they'll be both positive. The symmetry, the axis of symmetry rather, is x equals 1. The equation, I'll just copy that down again. F of x equals x squared minus 2x minus 3. The domain is all reals, like all parabolas we're working with here, go from negative infinity to positive infinity. So you can write all reals, or you can write it like in interval notation like I did. The range is a little trickier. We need to look at our vertex. That helps us, or our minimum. That helps us determine, notice the minimum is negative 4, and it's everything bigger than negative 4. So we can write that one of two ways. We can write bracket negative 4, infinity, or we can write y is greater than or equal to negative 4. When I draw this, let me do that again more slowly. When I draw this very slowly, notice we're decreasing on the left side of the parabola all the way until we get to the vertex. And then we are increasing on the other side of the parabola, on the right side. So the way we want to write that is we want to write that, remember, we're writing it in terms of x, and the x value of the vertex is 1. So we want to write from 1 to infinity, from 1 all the way to the right, we are increasing. And from negative infinity all the way up to 1, all on the left, we're decreasing. Thank you very much for watching, and come to class. We'll do some practicing groups, and I hope you learned something.